Hello, today let's solve this problem. This is a case 1 of the mirror integral, and we have the minus sign in the denominator. By the way, Wolfram Alpha couldn't solve this integral analytically, and you can see here, standard computation time exceeded. So let's get started. First, we subtract 1 and add 1 in the denominator. And then we define e minus 1 equals to a squared. And next, we will deal with this term. So we write 1 as sine squared plus cosine squared, and we write sine 2x by using the double angle formula. In this case, we can complete square. So we write the integral into this form. And then we do the substitution. We let x equals to half pi minus theta. From the mirror property for the sine and the cosine function respect to the pi over 2, we know sine x equals to cosine theta, and cosine x equals to sine theta. After plugging the substitution, we got here. And then we use this minus sign to flip the lower and upper limit. And we got here. And here we switch the cosine and sine term because they are inside the complete square. Because this is a definite integral, so we are free to choose the integration variable. So here we choose x as the integration variable. And note for these two equations, we will use them in the next slide. I copy them here. And then we add these two equations together. For the right-hand side, we can group them into a single integral. And then we make another substitution. We let u equals to sine x minus cosine x. And then we do the derivative to find du. After plugging the substitution, we got here. And note for the integrand function, it's even. So we can write it as 2 times the integral from 0 to 1. And the number 2 cancel out. So we got here. And then we just integrated. After plugging numbers, we got here. And then we plug in a, so we got the final answer. And don't forget to subscribe my channel and give a like.